Okay, this video is going to look at the pig program, kind of get you started on that. So if you want to flip your text over to page 141, we're going to be looking at exercise 14. Now, I posted a little snippet on how to use the random function that you'll need for this program. Of course, I'll go over it with you, but you should have already looked at that, and that's in Blackboard on the projects page. It says here using a random number statement, and that's what I'm talking about, and they've also mentioned that in the previous couple of exercises, which you haven't done, but you may have read. Create the logic for the dice game pig. Well, we know something already. It's a dice game, and you have two die and a pair of dice in which a player can compete with the computer. So there are two competitors here. One's a human and one is a computer. The object of the game is to score 100 points before the computer, or vice versa. The user and the computer take turns rolling a pair of dice. So that means that there's one pair of dice for both players, the values of which are determined randomly. And then there are some rules. But before we get into the rules, we know that each player or competitor here is going to have a score that's a running total, so that the first competitor to get to 100 or higher is the winner. So we're going to need a couple little things here. We're going to need a variable called, let's see, computer, and I'm just going to call it comp total. Set it equal to 0, and then we got another one called human, sorry, total, and set it equal to 0. We're going to have two die in the pair, so in each one of those is going to have its own variable. So die 1 and die 2, I'll call it. So that equals 0, and then num die 2. And again, I'm just going to get you going on this. I'm not going to do it for you, but I will get you going. All right, so that takes care of that. And then we're going to need a turn variable to determine whose turn it is. Now, if you jump ahead and look down at the bottom bullet point there on page 141, it says when the computer does not roll a 1 and can choose whether to roll again, generate a new random number value between 1 and 2. And let me stop that. All right. Use this value to decide whether the computer will continue to play or pass the turn to the player. Well, you can see here that we can let the human be 1, a value of 1, and the computer be a value of 2. So we need a turn variable. And we're going to need a random statement. And this is the syntax for it. And it'll give us a random number between 1 and 2 inclusive, or an integer of 1 or 2. And that's how that random statement works. We're going to need some constants, or at least one. I'm going to call this max score. Set it equal to 100. The reason you want to use a constant for this is because you may want to set that to a lower number, because it can take quite a while to get to the winning phase if people start losing their, if either of the competitors start losing their points. So if you have a named constant here, excuse me, you can set it equal to 25 or 30 or something like that. And then before you submit it, you can set it back to 100. Okay, what are we missing? I believe that's it for now. I'm sure I'm missing something, but let's see. Okay. Now there's a loop, but typically what I would recommend is you do the loop last. So let's just comment that out right there. We don't have to do a loop yet. Now, if you look at these rules, and we're about to look at them in depth, you'll see that there's very little difference between the logic for the human player and the logic for the computer player. So let's examine these. On a turn, each player rolls 2 dice. If no one digit appears, the dice values are added to the running total. So anything from 2 to 6 on either die or both die, that's the best scenario, right? If that happens, the player can choose whether to roll again or pass the turn to the other player. Now, the whole idea here is if you don't roll a 1 or 2 ones, then you get to add to your running total the face value of the dice. All right, and that goes to the computer as well as the human player. So that's one rule. The second bullet says if a 1 digit appears on only one die, nothing more is added to the player's total, so you don't get to keep anything on the dice, and it becomes the other player's turn. So you just lose your turn, basically. You don't get to gain anything from that. And then bullet number 3 is the worst possible scenario. If a 1 appears on both dice, not only is the player's turn over, but the player's entire accumulated score is reset to 0. So either way you look at this, that's the worst possible scenario because you lose all your points and your turn. And then we talked about 4 already. When the computer does not roll a 1 and can choose whether to roll again, you have to generate a random number value between 1 and 2 because the computer can't answer the question, do you want to roll or continue, like the human can. So that is the main difference between the logic for the human and the logic for the computer. So if you get the human logic done, you can sort of copy and paste it on the false side of an if statement, make a few modifications. When you get it all tweaked out, then you can put it inside your loop and test it. And I'm going to show you, some prompts that I put in my code that will help you with that. Because this is something of a complicated program. It's not terribly so. But. All right, so we're going to have to, the first thing we're going to have to do is set the dice. So we're going to have to use a random statement for that. Now, since they're both using the same pair of dice, it doesn't matter how this sets up. So there's 6 digits on the dice and there's no zeros, so we're going to set it to that. And then we can do die 2 same way, and that'll give us a random pseudo-random number between 1 and 6. Okay, so then we need an if statement. It's going to look at whose turn it is. If turn is equal, now I remember why I needed some extra constants for this. Num, let's just do human, set that equal to 1, and computer, set that equal to 2. Now that's our turn. That'll determine whose turn it is. Now you could type in 1 and 2, but it's just easier if you're looking at it to tell whose turn it is that way. So let's start off and do the humans first. A little bit easier that way for me anyway. Human. So if it's the human's turn, that's going to be true, right? And then else it would be whose turn? The computer's. But we'll worry about that in a minute. All right, so let's go in here. All right, so we've rolled the dice here. We've decided whose turn it is. And now we need to start looking at applying these rules. So we're going to need to look at die 1 and die 2. So if die 1, and so first thing, there are different ways to do this, but what I would recommend you do is look at the best case scenario first, because if that's the case, there's less to do. So if die 1 doesn't have a 1 and die 2 doesn't have a 1, that's the best case scenario, because that means they've got between a 2 and a 6 on both of them. So how am I going to do that? Well, if die 1 is greater than 1, that means it doesn't have a 1 on it, right? And die 2 is greater than 1, that means it doesn't have a 1 on either one of them. If that's true, then I'll come in here and basically just add dice scores to human total. All right, these are just comments. I'm going to let you figure out the logic here. And then prompt to continue or to roll or pass. Now, why would you want to do that? Well, if you've ever played very much in the way of card games, you know that every time you roll a set of dice, if you have a good roll or a good hand, your chances get ever increasingly higher that the next hand's not going to be as good. So if you roll 3 good hands in a row, it might behoove you to pass before the bad hand comes up and pass it on to the other player, right? Okay. All right, so what if that's not true? Well, if that's not true, it just tells us that we have 1 1-digit or 2 1-digits, right? We don't know which. So let's do an else if die 1 equals 1 and die 2 equals 1. That tells us they both equal 1. Now that's the worst possible case, right? Then, and I left my then off, sorry, up here. Then what? All right, so we're going to come over here and that's a bad situation. So set total points to 0 because they're going to lose that, and set turn equal to the computer. All right. Well, now if it's not either one of those, it has to be what? A 1 on only one of those. So and then we come in here and we don't lose the points, but we don't get any points. We just set the turn equal to the computer. All right. And that's pretty much the way that works. All right, so once you get this completed, then you can take all of this and push it out over here and just modify this, because the computer is not going to be able to be prompted to roll or pass. It can't make that decision. And if you look at the book, it says that you just use a random function to set the turn, just like we did right here. Same deal, okay? Now you'll have to change, set turn from computer to human, and you'll have to change the total accumulators from one to the other and that kind of thing. But other than that, that's pretty much it. And then all you have to do is stick everything up in here in a loop. Okay. So that kind of gives you a good heads up on how all this works, and I'm going to let you struggle through with that. But in the meantime, I'm going to get this set up and show you a run of the one that I did. So bear with me. I'll be right back. Alrighty. Here we go. This is turn goes to the user. So the user got the first random roll or turn. And it looks like both of these dies don't have any ones. So it's going to be 7 to the user. So the human user gets prompted to pass or roll. Now notice I've set 1 equals roll, 2 equals pass, so that I'm just setting the turn variable to 1 or 2. So if it's 1, when it comes back around again, it's still the human's turn. If it's 2, when it comes back around again, it becomes the computer's turn. So that's a little trick that you might want to employ. So let's roll it again. All right, so the user, a human user, has 7, computer has 0. Uh-oh, looks like the user crapped out. And that's exactly what happened. Now notice the totals are back to 0. So the turn goes to the computer, and 11, and that's what we have. So you'll need to put these prompts in strategic places so that you can tell what's going on, that the totals are getting updated correctly, the turn is getting swapped the way it's supposed to, and that it terminates the way it's supposed to. Turn gets shifted to the user. That's a valid. You want to roll again? Sure, why not? Now notice again that the user gets prompted to roll or pass, but the computer just randomly does it because the computer can't make that decision. All right. Uh-oh. Looks like the human crapped out again. Wow. All right, the computer got a good roll. Computer got another good roll. The human user gets it, and he got a good roll. Continue, yes. All right, well, they don't lose all their points, but it gets swapped back to the computer because he got a 1. So the computer should come up next, and it does. The computer got 7. And if you're keeping up with this, now the computer loses its turn, gets passed back to the human. And you can see that it did go back to the human, and the human got a good roll. Let's roll again. Yeah, another good roll. Roll again. Another good roll. I'm going to pass this time because I am kind of scared of that. That's a good thing because the computer got hosed with a 1. Now it goes back to me again. All right. And I lost it. Oh, well. I've got some funky messages in there. You don't have to do all that. All right. Let's roll again. User gets a pretty good roll. Like the user's coming on strong here. Oh, yeah. Let's pass. Oh, shouldn't have done that probably. Goes back to me anyway. Roll again. Ooh, let's pass. I shouldn't have done that. Dang. All right, I'm getting all excited about this game. I don't know why I've done it a million times. Uh-oh, got a 1. It gets sent back to the computer. Ooh, computer got 12. Computer's coming on big time. Oh, computer gets it again. That's a good one. Ooh, the computer's coming on strong. Crap. I'm going to go again. I can't take chances. Ah. What am I talking about? It's beating my rear end. Okay. User gets 12. Oh, the human won. So there's the final score. 101 to 89. And there you have it, folks. Hopefully you'll be able to code this puppy and see who's winning and who's losing and whose turn it is and what the scores are and when they get wiped out and what their dice rolls are. So you're going to have to keep track of all of that. That's why it's better to set this to about 25 right here while you're testing it, because you can get up to like 89 or 90 and then all of a sudden have them crap out and have to start all over again. So it's probably going to be better that way. All righty, well, hope you enjoyed this. Good luck.